x cubed minus 8x squared minus 5x plus 84 over x squared minus 1, which is less than 0. Okay, so should be hopefully easy to see that I have two vertical asymptotes at -1 and +1. And then I also care about the x-intercepts here, but to deal with that polynomial, I can't get away with factoring that by grouping. So I'm going to have to do like the solving that we would have done last chapter with the long divisions to get at that guy. So I'm going to go and just take a look at the graph, and once I look at the x-intercepts, I'll double check to make sure that those are would be on my possible rational zeros list. Just to make sure, in this case, they just have to be a factor of 84. So I'll probably just check it in my head to deal with that. And I'm going to hope, because I'm the one that made this problem, that I didn't do something silly and pick like gigantic zeros, but I doubt I did. I probably picked something pretty easy to see. So let's see, we have -3, +4, and then +7. And each one of those is divides 84, so I'm good with each one of those. To just kind of confirm that these are indeed exactly the zeros, and it's not something silly going on like, like it's actually not -2.99 or something. Although that seems unlikely. I'm just going to go ahead and do my synthetic division here. Using each one of these 3 zeros. And I can see that they all did work. So on my number line here, it's going to be pretty busy. Let's see, I got -3, -1, +1, +4, and +7. Gee golly willikers! It's a lot of places to check here. Since this is a less strict less than, I'm going to indicate each one of these with the open circle for the asymptotes and the zero. Since it was a less than, I don't have to worry about distinguishing between everybody gets the same open zero. And let's pick some values. So I got -4 here, -2 there, 0 there, 2 there, 5 there, and then 8 there. So many to check. Since I have to check so many of these, I'm going to use my calculator to do this. So I'm going to just type my rational function into the calculator, because it'll make inputting these values a little bit quicker since there's so many x's. You know what I mean, guys? You could do it all by hand too if you wanted to, but I am not about that life. Let's get her done and be efficient about the whole thing. So there's that. So now go and I'll do bars y1, and I'll just input my test values in here. And I'm not even going to bother to record the number. I'm just going to record whether that value is positive or negative, since that's all I really need in order to adequately answer this question. negative 2 gives me a positive. And then the 0, obviously that gives me a negative, it's just 84 over negative 1. I don't really need to do that in my calculator. You could if you wanted to, but that one I could plug in with my brain. And then that one's positive. The next one is going to be negative, I suspect. Whoa! It's a 50-50 guess. I really just kind of guessed. I noticed that it looks like the sign is just alternating, which is not uncommon. And the last one is the 8, which is also positive. So the places I'm interested in were the places that are less than 0. So I'm interested in these 3 intervals. So I have negative infinity to negative 3, negative 1 to positive 1, and then 4 to 7. Does that feel okay, Teresa? It was probably not thinking that you had to go all the way back to the previous chapter solving to do the solving piece. And after we pointed that out, you probably would have been like, okay, stop doing this. But I just went ahead and did the whole thing anyways because I got excited, you know. Plus, then you get to see the answer. So when you try to do it again yourself, at least you're like, okay, I know what I'm looking to get at the end here. Who else? Yes, Caroline.
Number 29,
29, you say?
yes.
Okay. So this is a solving problem. And the first thing that I want to do to solve this equation is to clear the fractions. So I'm going to look for the least common denominator for all the denominators. In order to do that, though, I'm going to factor that last trinomial because I can't really see what the LCD would be until I've done that. And now it should be easy to see that the LCD is just going to be x plus 5 times x minus 2. Multiply both sides. So when I do that, I get 3x times x minus 2 plus 1 times x plus 5 equals 7. So let's go ahead and multiply this stuff out and get everything onto one side. So that's 3x squared minus 6 plus 1x plus 5, and then I'll subtract the 7 over there all at the same time. And if I combine my like terms, 3x squared minus 5x minus 2 is equal to 0. And now you could try to factor that, but to factor it by hand, since the leading coefficient is 1, you'd have to do that long factoring thing where you do the grouping, which is fine, you can do that. I would do the quadratic formula personally because I think that's going to be the same amount of work as doing long factoring. So, and I'm guaranteed to get an answer from the quadratic formula. The long factoring may not even work. You know, I'm going to be searching for like those two numbers that whatever to whatever, and they just might not exist. So, I'm just going to go ahead and do it this way. So negative b plus or minus b squared minus 4 times a times c. Notice that the c is negative, that's why I'm adding there. So 25 plus 24 is 49, and the square root of 49 is 7. So 7, or 5 plus 7 is 12, divided by 6 is 2. And then 5 minus 7 is negative 2, divided by 6 is negative 3. But remember, I still need to make sure I go back and check. In my check, what I really care about is a zero denominator. Notice if I plug 2 in, that would make a zero denominator in 2 places, so I'm going to discard that solution and only accept the negative 1/3. Does that feel okay? No problem. Ben?
Do number 43, please.
43? Yeah. So we have x plus 1 over x greater than or equal to 0. So I have a VA at 0 and an x-intercept at -1. Any questions on how I came up with those?
The x-intercept is done by...
Numerator set to 0.
Okay. Yeah. Oh, yeah. Wait, again.
So I'm going to go ahead and draw this stuff on the number line. So the 0, or the vertical asymptote, gets the open circle. And because this is an or equal to, I'm going to use a closed circle for the x-intercept. Right?
Yeah.
So I need to pick a value over here, so maybe -1, a value, oh my goodness, what did I do here, guys? Let me, this is all goofy. The negative things go on the left side, the positive things go on the right side. There's that. That's better. Sorry. So maybe we'll pick -2. And we'll pick like -0.5. And we'll pick 1. Sound good? Okay, when I plug -2 in, I get -1 over 2, so that, or -2, so that's positive. When I plug -1/2 in, I get 1/2 over -1/2, so that's going to be negative. And when I plug 1 in, I get 2 over 1, that's positive. So the pieces I'm interested in are here and here. So this piece is going to become -infinity to -1 with the bracket. And then this piece becomes 0 to +infinity, but with parentheses. Okay?
Okay, so when the denominator is like, I don't know, like perfect square or anything, it's like set to the second power, will it be multiple vertical asymptotes?
You mean if this was x squared?
Yeah, if it was like x.
Well, it would be still 1 vertical asymptote. I mean, the solution has multiplicity 2, but that doesn't really affect anything here.
Okay, so like, let's say it's like x squared minus 1.
Okay.
Like, then you do x squared minus 1 equals 0.
Sure.
And then it'd be positive and -1.
Yes.
So you do positive and negative.
Agreed.
You have open circle at +1 and -1.
Correct.
It can't equal that.
Correct.
Okay.
Yes. 100%. No problem. What else you guys want to talk about? Go ahead, Julia. 33. Oh, this is the tough one, huh? Okay. So this was one that when 4th hour asked about it, took me like 10 minutes to remember how to do this, but now I got it. So this is a story problem. It says the West Michigan Whitecaps are trying to maximize their profits. 2 weeks ago, they found that if they sold $5 or tickets for $5 each, they were able to sell 4,000 tickets. Last week, when they sold their tickets for $8, they only sold 3,000 tickets. How much should they sell tickets for in order to maximize their profits? Okay, so one thing that we can say right away, the profit is going to be the number of tickets that you sell times the price that you sell them. right? Everybody agree with that? So week 1, we had 4,000 tickets at $5. So that would be $20,000. Week 2, we sold 3,000 tickets at $8. So that would have been $24,000. So I can conclude one thing right away. The price that's going to maximize my profits can't be less than $5, right? Because we made more money when we charged for $8, so it can't be anything over there because you'd expect as the price goes up, the number of tickets goes up. So it's either going to be somewhere between $5 and $8, or like we've hit a maximum and come back down, and like those are like the profits. Or it could be somewhere where like this is the $8 and it's still better somewhere after that. It's going to be one of those two things, right? So what I'm going to observe here is I want to relate the increase in price to the number of, or to the decrease in tickets. So my profit function, I'm going to say that 5 plus x is going to be my new cost. Okay, so x is going to be the amount we're going to be increasing the price of tickets by. And I know that we're going to be losing something from that 4,000 total that we had when we were charging $5, right? So what I'm going to do there is the difference between 4,000 and 3,000 is 1,000. You guys agree with that? And the price increase was $3. So basically like 333 tickets we lose for every $1 in price we change. Everybody okay with that? So I'm just going to write that as a fraction of 1,000 over 3 instead of 333.3 because it's a repeating 3 and I want to get this as accurate as I can. Julie, are you okay with how I set that up? Now that's a clever way of setting this up. That's not trivial or not obvious on how to do that. But I think that works. So now that I have this set up, I'm going to find the maximum for this. So I'm just going to do that graphically with my calculator. And I'm assuming that x having a maximum of 10 will be plenty. That if you're going to go, $15 for a ticket and we're already seeing it, you can't really get that low even because if we're losing 330 tickets a shot for each dollar, and we have 4,000 to work with, basically you can only increase it by $12 or something and not have negative tickets sold. So I think that's probably good. My profit, well, 0 can be the minimum, but the maximum, it's going to be bigger than 24,000, right? So I don't know what that's really going to be. I'm going to pick 30,000 just to be safe. That seems like more than enough. And then let's give this guy a go. Let's see what we get. So there's my function. So my maximum is somewhere over here, right? So I'll find that second trace and then choose the maximum command. Asks me for a left bound or right bound and a guess, so I'm just kind of watching my y coordinate. So since I'm moving to the left, I'm waiting for that to move from increasing to decreasing. And now they're starting to go down. So I was at 24,000 something, now I'm up less than that, so I'll press enter. And I'll go right, and I'm watching my y coordinate, waiting for it to stop increasing. So there I saw it stopped increasing, so I'll press enter and then hit my guess. And it looks like the x value is 3.5. And that'll give us $24,000.83. So this is 3.5 for x means $8.50 per ticket. And then the 24,083 would be the profit. We managed to squeeze an extra 83 bucks by charging 50 more cents, but you know, it's $83 we didn't have before. Well, the cost is 5 plus x. So if x is 3.5, then the price per ticket is 5 plus 3.5 or 8.5. Does that feel okay? So again, this was a kind of a tricky setup one and not an obvious way to set that up. But once you've seen it done, it's like, okay, I could probably do that again if I had to. That's kind of clever, but should feel doable, at least now that you've seen an example of doing it. Who's next? Okay. Well, that's all right. We'll stop here.